A modern video game is a rigid artifact, constructed from static lines of code and finite mathematical limits. However, the code and the graphics are merely the delivery mechanism. The actual experience occurs exclusively within the fluid, unpredictable environment of the human mind. Navigating the gap between these two states requires the designer to practice a specific form of active listening. This isn't just hearing feedback. It's a thoughtful, analytical observation of 5 distinct nodes: the development team, the target audience, the game's internal logic, the client's needs, and the designer's own subconscious. Listening to yourself is often the most difficult requirement. To understand why a specific mechanic works, a designer must ruthlessly dissect their own subjective feelings, translating a vague sense of fun or frustration into a clear statement of cause and effect. This process is complicated by the Heisenberg principle of introspection. The moment you consciously analyze an experience, you disrupt its nature. Like typing while focusing on individual fingers, observation causes the organic flow to stutter and fade. Learning to observe an experience without destroying it is the first hurdle in systemic design. It allows the designer to collect the raw data of human emotion without the distortion of overanalysis. Because designers are limited by their own personal biases, they must use empathy to project themselves into the perspective of the player. When Walt Disney inspected Disneyland during construction, he would frequently crouch to the ground to see exactly how the park's geometry appeared to a child. Mapping this player perspective begins with demographics. This involves grouping audiences by external, quantifiable factors like age and gender to predict general playstyles. Beyond these external traits lies psychographics, a deeper grouping based on internal desires and lifestyle choices. This focuses on the specific internal pleasures a player is seeking when they engage with a system. Psychographics explain why two players with identical demographic profiles might hate the same game. One may be looking for the relaxation of a repetitive task, while the other is driven by the high-stress adrenaline of a competitive leaderboard. While demographics identify who is playing, psychographics reveal why mechanics are pleasurable, allowing the designer to reverse engineer the experience for a specific psychological profile. Gameplay is only possible because the human brain possesses specific processing tools. It simplifies complex reality into workable models, maintains focus on relevant data, uses everyday imagination to solve problems, and employs empathy to project the self into the game world. These 4 pillars form the subconscious architecture that sustains any game experience. The goal of manipulating these mental pillars is to reach a state of flow, a condition where the player is so energized and focused that time seems to disappear. This occurs in a specific channel where the game's challenge level perfectly matches the player's skill. Staying in this channel requires a constant cycle of tension and release. The game must push the player's limits to create excitement, then provide moments of relaxation to prevent exhaustion, creating a steady oscillation of engagement. If the mechanics demand more than the player can currently provide, the challenge exceeds their skill. The flow state breaks, replaced immediately by anxiety and frustration. Conversely, when a player masters the system and the game fails to introduce new friction, their skill outpaces the challenge. Focus is lost, and the experience flatlines into boredom. Flow is the result of a highly engineered psychological equilibrium, dependent entirely on the underlying mathematical rules of the game. When we remove the thematic layers of art, story, and technology, we find the procedural relationships that define the game's structure. This is the mechanical tetrad, the core interactions involving space, objects, actions, and rules. The first mechanic is space. Every game operates within a mathematically constructed magic circle, which defines the relationship between different points in the game world, even if that world is purely abstract. The second mechanic is rules, which are the most fundamental part of the system. David Parlett's analysis of game rules reveals a clear hierarchy between what the player does and how the system functions. Foundational rules are the invisible, underlying mathematical structures. They represent the game's state and how it changes, such as a formula that increases a power value by a random number. These contrast with operational rules, which are the tangible actions a player performs, like rolling a physical die, to interact with those foundational values. The third mechanic is skill. A designer must distinguish between virtual character skills and the actual real-world skills required from the human player, such as memory or physical dexterity. Some skills are hidden within the game's design. In the Racer RC Pro-Am, players realized that firing a weapon required releasing the accelerator. To keep their speed, they had to invent a sideways thumb grip to hit both buttons at once, turning a simple race into a complex challenge of manual dexterity. These core mechanics act as the wireframe of the experience. If the foundational rules or the skill requirements are poorly balanced, the intended psychological response will fail to trigger. A mechanical system is only effective if its parts are balanced. Without a mathematically fair measurement of skill, the player has no reason to remain invested in the outcome. Designers maintain this balance by appealing to two deep human drives: the instinct to compete for status and the instinct to cooperate for group survival. The arcade game Joust serves as a model for this balance. It creates a logic tree that pits these two evolutionary drives against each other in real time. During a team wave, the system rewards cooperation. If both players survive by working together, they are both granted a significant absolute score bonus. However, gladiator waves introduce tension by incentivizing betrayal. The system grants a relative score spike to the first player who defeats the other, forcing a shift from cooperation to competition. By tuning these opposing forces, the designer creates a system that navigates the player's social instincts, alternating between status-seeking and survival-based cooperation to keep the experience dynamic. This systemic balance is most visible in game economies. In its strictest sense, an economy exists whenever a player must navigate two meaningful choices: how to earn a resource and how to spend it. Balancing this loop requires the simultaneous management of fairness, challenge, player time, and the freedom to make meaningful choices. A single error in the math can create a ripple effect throughout the entire game. If an item is too expensive, the flow of currency chokes. The earning phase inflates, forcing the player into an unsustainable time grind. When the economy is out of balance, it forces the player out of the flow channel. The loop breaks, and the experience degrades into either frustration or boredom. Effective game design is a process of precise translation. By linking rigid mathematical rules and balanced economies to the fluid mechanics of human psychology, the designer builds an invisible architecture that reliably shapes